So today we're going to be graphing equations, and now this is going to be similar to one of our previous videos where we're going to be using, in this case, point-slope form. And the idea being is that we're given both a point and a slope, so we can literally just take the information, plug it in, and solve it. And now, if we want to remember what is point-slope form, well, point-slope form is y minus my y1, y minus my y1 equals my slope times my x minus my x coordinate, or what we call x1. And so what we've got is we've got three pieces of information right here. We have our y1, which is very crudely drawn right here. Sorry about that. M and my x1. And I'm literally just going to take these three pieces of information, plug it in, and solve it. So we know that our coordinates are always listed in x comma y order, because remember, this is alphabetical order. We always list coordinates in alphabetical order. Now, let's go ahead and see what happens. So if I take y minus, and I have a y1 of 6, that's going to equal my slope, which is 3, times x minus my x1, which is 2. Boom. And so now I've only got 2 steps in order to turn this into slope-intercept form. So what we're going to do is we are going to, first step is I'm going to distribute that 3 to both these terms, which is going to leave me with a y minus 6 over here. 3 times x gives me a 3x. 3 times negative 2 gives me a negative 6. So now that I've cleaned up this side, there's nothing left I can simplify over here. Now I'm going to come to the other side and say, let's get rid of anything attached to the y. I'm going to get rid of that minus 6 by adding 6. That's going to cancel out. I'm going to be left with y equals 3x. Now this is our actual equation. What many people want to do, and that is okay, is they'll put a plus 0 in there. And what that plus 0 tells us is not necessary information, but it does tell us that our intercept is going to be at, actually I'm going to do this in, let's do this in red. Our intercept is going to be at 0. So I'm going to put my point right here. And I know my slope is going to be up 3, 1, 2, 3, over 1. Boom. And we have ourselves an equation of a line in slope-intercept form that we used with nothing more than a point and a slope. So the 2 pieces of information typically that we do need to label are going to be that y-intercept, which is going to say, okay, that's at 0, 0. And then I'm going to label the line and say, okay, y equals 3x. And again, this is going to come in handy later on when we have more than one graph. So always list your intercept, and always list your line. So let's do that one more time with these. So we know our equation is going to be y minus y1 equals m times x minus x1. So y1, m, x1. And I'm going to take these 3 pieces of information and stick them in. So it's going to be y minus equals m, x minus. My y1 is negative 8. The slope is 4. My x1 is negative 4. Now the first thing that should jump out at you is the fact that we have double negatives on both sides. And we know that a negative is going to end up being plus a positive. Same over here, a negative is going to be plus a positive. Because it's like taking away a negative value is the same thing as giving you value. If I said that you owed me $4 and I'm going to take that away, it's the same thing as if somebody handed you $4. Perfect. So we've got this. And again, we have 2 steps. My first step looking over here is I can get rid of these sets of parentheses by distributing this 4. So I'm going to get a y plus 4 is equal to 4x plus 16. And now that there's nothing left over here to simplify because I can't combine unlike terms, I turn to the other side and say, let's get rid of anything that I don't need. In order to keep the equation balanced, I do that on both sides. And so I'll get a y is equal to 4x plus 12. And there we go. And now we run into our first issue of sorts. And the first issue that we see is that pause for a second. My 8 all of a sudden turned into a 4. So just be aware that that 8 should actually be, or that 4 should actually be an 8, which is going to make this 16 minus 8 is going to be an 8. So regardless, we still experience the same problem. I have 5 boxes and I need to go up 8. Now what I could do is I could say it's off the graph and just come in from wherever I'm able to. But typically speaking, at this level, we want to include the y-intercept in our graph, which means that if I count by ones, that's not going to be enough. But if we stop and we think for a moment, there is a way I can fit 8 into these 5 boxes. And how do you think that would be? Well, we're going to count each box by 2. So I'm going to go ahead and I'm going to label that. And I'm going to say each box is worth 2 by putting 2's by my y and 2's by my x's. This prevents us from having to label each individual line, like often students end up having to do. This lets us know that just we count by 2's on everything. So that 8, instead of going 1, 2, 3, 4, 5, 6, 7, 8, and if it were a bigger number going way up on your paper, it allows us to say, okay, 2, 4, 6, 8. Boom. There we go. I got 8 on my box of 4. Now, because each box is worth 2, one of the things that I noticed with the slope is that it's going to be up 4 over 1, which still doesn't fit up here. So I'm going to have to reverse that. And the opposite of plus 4 over plus 1 is going to be minus 4 over minus 1, because those both reduce down to the same thing, which means instead of going up, I could go down, but I'd also have to go, instead of going right, go left. So I'm going to go down 4, so 2, 4 over 1. And here's an interesting side bit. I could graph that as my line, but if I go down another 4, 2, 4 over 1, what I notice is that if I counted by ones, so 1, 2, 3, 4, and over 1, or if I counted by blocks, 1, 2, 3, 4 over 1, I end up at the same line. So the fun part about slope is the fact that if your graph has been scaled equally, you don't need to count by individual units. You can still count by whole blocks, regardless of how many the blocks are worth. If these were by 10s, I could still go down 4 blocks, left 1 block. Because again, if I went by 10s, that would be negative 40 over negative 10, which still reduces down to my original slope. So again, the fun part about slope is that no matter what your scale is, you can always treat slope as a counting of the blocks. And again, at this level, I want to list at least my y-intercept, which is going to be 0, 8. And I want to label my line, which is y equals 4x plus 8. Another thing that we may eventually want to label is we want to label our x-intercept. At this point, I can blatantly see it. I know that it's on the line, it's on that point. That's going to be negative 2, 0. But really, at this point, we're not quite at where we need to start labeling that. When we hit standard form, we will start going over those. So what I want you to try now is I want you to pause the video. I want you to try number 5, unpause it when you're done, and see how you did. Okay, so let's take a look. I know that I have a point and a slope, so I'm going to use my equation for point-slope form, which is going to tell me that I need y minus my y-coordinate equals my slope times my x minus my x-coordinate. I'm just going to plug these in. Y minus equals x minus, boom. I'm going to plug in for my y a 9, for my slope a negative 3, for my x a negative 4. We noticed that I have a double negative over here, not over there. So the left side does not change, it stays y minus 9, but the right side turns into x plus 4. And again, what that allows me to do is that allows me to clean up this right-hand side by distributing that negative 3. So y minus 9 is negative 3x minus 12. Now that I've cleaned up the right-hand side, I'm going to isolate the y on the left by adding my 9. And I'll get y is equal to negative 3x minus 3. 2 pieces of information I gather from that. I have an intercept at negative 3. and I want to go down 3 over 1, but I don't have enough space. So instead of going down 3 over 1, I'm going to go up 3, left 1. Remember, because these are the same thing. Negative 3 over 1 is negative 3. 3 over negative 1 is negative 3. They're both equivalent to our slope. So I'm going to go up 3 and back 1. Up 3, back 1. And there's my line. And again, the only thing that's required at this point to label, typically at this level, is going to be your y-intercept, which is 0, negative 3, and my line, which is y equals negative 3x minus 3. If you want to be an overachiever, I have that point right there, which is my x-intercept. Again, typically we want to list both intercepts, but we'll get there eventually, which is going to be at negative 1, comma, 0. Perfect. And so, depending on how you did with that, let's do one more. And again, this has a slope of a fraction, so why don't you go ahead and pause the video, try and work the fraction, and see what you get. Unpause it when you're done. Let's see how you do. Okay, so there's going to be 2 ways to work this. The way that I like to show is going to be a way where we're going to clear the fraction. So let's go ahead and get that started. So I have y minus equals my slope, x minus my x1. So y1, my m, and my x1. So y minus I have a y1 of 4, an x1 of negative 4, and a slope of negative 1/2. Now, first things first, I notice that my double negative is going to cancel out. So I'm going to end up with a y minus 4 equals negative 1/2 x plus 4. And now, most of us look at this as one of 2 ways. And we say, hey, I have a fraction. I could possibly want to clear the fraction, which would mean that at this point, if I cleared the fraction, I would have a couple steps left. So y minus 4 is equal to negative 1/2 x plus 4. And remember, the way that we clear a fraction is we take the entire equation and I multiply it by the denominator, 2, so that these cancel out. And I'm left with, on the right-hand side, a negative 1 x plus 4. Remember, we don't go inside those parentheses because I only distribute once. I don't go inside twice. So I'm only distributing right here, and right there. Now everything is, I guess you would say, standardized. There's no more fractions. So we can work it as we would normally work it. So distribute my negative 1 to y minus 8 is equal to negative x minus 4. Then I would add my 8, which would cancel that out over there. Get it 2y is negative x plus 4. If you believe that, it's a negative x. The last thing I would do is I'd divide everything by 2, which would cause me to say y is equal to negative 1/2 x plus 2. Because negative 1 over 2, x, 4 over 2 reduces down to 2. And I'd end up with this. Some of you, however, might notice that this, if I just work with the fraction, that 4 can be divided in half. So we don't actually need to worry about clearing it. It will clear itself. So we could say, hey, when I distribute this, it's okay that I leave a fraction in the beginning. Y minus 4 is negative 1/2 x. Don't need to worry about what this works out to. I'm just going to leave it. But half of 4 is 2. Positive, negative, make a negative, which allows me to, in a much shorter way, isolate my y. Now, it doesn't matter which way you go. Typically, I like to show this way because it works in a process. Later on, we're going to use an elimination. But we do know that this way will be faster. So pick the method you like. Either way, we're going to graph an equation where it's got an intercept of 2, and it goes down 1 over 2, down 1 over 2. Or vice versa, up 1 and back 2, up 1 and back 2. And that's the line that I'm going to graph. Let's see what it looks like and what we need to label. two things. Label my 0, 2, my y-intercept. I'm going to say y equals -1 half x plus 2. There's my line. If I want to be super cool, I'm going to go ahead and label that as a 4, 0 for my x-intercept. And there we go.